Hello students. Hello and welcome to this video. In this video we will solve question number 371 to 380 of permutations and combinations. The link to download the PDF will be in description, as well as at the end I will show you my website where you can download the books and maintain the versions so that you can maintain an updated copy of the books. So without further ado, let's get started. Question 371 says that find the total number of 6-digit numbers x1 through x6, where x1, x2 all are a digit, having the property x1 through x6 in ascending order, with the exception that x2 can be equal to x3 and x5 can be equal to x6. So the given condition can be broken into 4 cases. The first case is the numbers are strictly in increasing order. The second case is the number are in increasing order but x2 is equal to x3. Third case is number are in increasing order but x5 is equal to x6. And the last condition is when x2 is equal to x3 and x5 is equal to x6. So in the first case, we have to select 6 digits out of 9, that is 9c6. Then in this one we will select 5 digits, that is 9c5. In this one also we will select 5, so 9c5. In the last case we will select 4, so 9c4. You add them, you will get 11c6. Question 372 says that if all the 6-digit number x1 through x6 with 0 less than x1 through x6 again in increasing order are arranged in the increasing order, then find the sum of the digits in the 72nd number. So our most significant digit cannot be 0. 0 just cannot be part of x1 through x6 because all digits are greater than 0, right? So 0 cannot be part of this. So we can't take 11. We take 12. Okay. The reason is we can't take 11 is because x2 is always greater than x1, right? In all cases, in this case, x2 is always greater than x1, so we take 12. Now remaining 4 positions can be filled in 7c4 ways. So remaining digits can be picked from 3, 4, 5, 6, 7, 8, 9. Then we have 13. Now we have 6 digits from which we have to choose 4. 6 will be 4, 5, 6, 7, 8, 9. That is 15 ways. Similarly for 14 it is 5c4. For 15 it would be 1. We won't have 16 because we won't have 4 digits left. After 16, the digits greater than 6 are 7, 8, 9. So only 3 digits. 3 plus 2 digits of 16, which will make 5 digits. But the number is of 6 digits, so we can't have 16. So we move on and take next possible, that is 23. We can't take 22, right? Because both 2's are equal. So we take 23. So it will give 6c4, that is 15. So number of digits would be whatever. We don't care. So till now we have 71 numbers. So 72nd would be next possible biggest digit. So 24. And next possible smallest digit is 5, 6, 7, 8. And sum of digits is 32. Question 373 says that let there be n greater than 3 circles in the plane. Find the value of n for which the number of radical centers is equal to number of radical x's. Assume that all radical x's and radical centers exist and are different. Now to solve this question, you need to know what are radical x's and radical centers. We have not yet studied coordinate geometry, and if you have not studied coordinate geometry on your own, then you cannot solve this problem. It is a very easy problem, but you cannot solve it unless you know what are radical axes and radical centers. So you can skip this question and come back later when you have solved coordinate geometry. So to form a radical center, we need 3 circles. The total number of radical circles is nc3. The total number of radical axes is nc2. Now nc2 is equal to nc3, which is given. So n is equal to 5 from this. Next question is find the number of functions f from the set a is equal to 0, 1, 2 into the set b is equal to 0 through 7. So 8 values here. such that f of I less than equal to f of j for I less than j and ij are in the set of A. So number of ways are number of one-to-one mapping plus number of mapping in which 0 and 1 map to the same element and 2 maps to a different element, plus 0 maps to a different element and 1 and 2 map to the same element, plus number of constant functions. So we get 8c3 plus 8c2 plus 8c2 plus 8c1, that is 10c3. Question 375 says that show that the number of ways of selecting n objects out of 3n objects, n of which are alike and rest are different, is 2 to the power 2n minus 1 plus 2n factorial by n factorial whole square. So we can choose 0 to n objects from n identical objects in one way. However, we can choose from 0 to n objects from 2n different objects in 2nc0, 2nc1 up to 2ncn. Now we know from binomial theorem that this relation exists. Okay, if you are not studying binomial theorem, again you can skip or just take it on the face value. So once we have this relationship, what we do is we observe there are 2n plus 1 elements here, or terms, 0 to 2n, so 2n plus 1 elements. So what we do is we make it 2n plus 2. We add 2ncn here and we add 2ncn here. Now there will be 2n plus 2 elements. So these are n plus 1 elements, and then we will have 2ncn onwards here. So that will be, this side will be half of that. Okay. So that is equal to 2 to the power 2n minus 1. And then we had added 2ncn, that will be there. Now 2ncn is 2n factorial divided by n factorial whole square, and we have our answer. Question 376 says that in a chess tournament, each participant was supposed to play exactly one game with each of the others. However, 2 participants withdrew after having played exactly 3 games each, but not with each other. The total number of games played in the tournament was 84. How many participants were there in all? So we let number of players to be n. For n minus 2, number of games would be n minus 2c2. The 2 players played 3 games each, that is n minus 2c2 plus 6. 3 games each multiplied by 2 is 6. That is given as 84. Now n minus 2c2 is n minus 2 multiplied by n minus 3 divided by 2. And 6 we subtract, we get 78. So we bring everything to one side. We have n square minus 5n minus 150 is equal to 0. Factorize n is equal to 15. Question 377 says that a positive integer n is called strictly ascending if its digits are in the increasing order. For example, 2368 and 147 are strictly ascending, but 43679 is not, because 3 is smaller than 4. Find the number of strictly ascending numbers less than 10 to the power 9. So if something is 10 to the power 9 and less than that, there will be at most 9 digits. So for 1 digit, we have 9c1 numbers. For 2 digits, we have 9c2 and so on. So the total number of numbers is 2 to the power n minus 1. Because for n digits, it would be 9c9. You add 9c1 to 9c9. That would be 2 to the power 9 minus 1. Because nc0 is missing, so we have to add that to both sides. I mean, add to one side and then you add to another side, and that's how you solve the problem. No, you don't add to another side, you simply subtract it. Okay? Question 378 has this diagram. Now there are 8 clay targets arranged in 3 columns to be shot by 8 bullets. Find the number of ways in which they can be shot such that no target is shot before all the targets below it, if any, are first shot. So for example, take this. So you cannot shoot the top 2 one unless this bottom one is shot. Once you have shot the bottom one, you can shoot the middle one, not before shooting the bottom one. Once you have shot these 2, you can shoot the top one. Similarly for other 2. So we have a total of 8 factorial ways possible. For each legal way, we can reorder within each column in 3 factorial, 2 factorial and 3 factorial ways to obtain any of the 8 factorial orderings, legal or illegal. Thus, the number of ways to shoot the targets is 8 factorial divided by 3 factorial multiplied by 3 factorial multiplied by 2 factorial, which is 560. Question 379 says that how many hexagons can be constructed by joining the vertices of a twin decagon, which is 15-sided polygon, if none of the sides of the hexagon is also the side of the twin decagon? Now, to understand the answer of this, it would be best if you take pen and paper and draw it. Okay. If you don't pay attention here, you will miss the solution. It is a bit involving. Consider a vertex A of twin decagon. Suppose A is not a vertex of hexagon. Arrange 9 balls in the form of a circle of which one is A. We can choose 6 out of 9 gaps in which to place a green ball, a vertex of hexagon, to ensure that no two green balls are adjacent. This ensures that no side of hexagon coincides with twin decagon. Now we label the vertices, there should be E here, in alphabetical order as we go clockwise around the circle. There are 96 ways to do this. Now suppose A is a vertex of hexagon. We color it green. We can arrange 9 blue balls around A to form a circle which includes this ball. Doing this creates 10 gaps in which to place green balls, but 2 of them are adjacent to A, leaving 8 gaps. We can choose 5 out of the remaining 18 8C5 ways. So total number of hexagon possible is 9C6 plus 8C5. So see, there is a bit of geometry involved in this, and if you really put this on pen and paper, it will be very easy. Let me know if you have difficulty understanding this solution, and I will try to create some graphics for this and show it. Question 380 says that let A be a set of n greater than or equal to 3 distinct elements. Find the number of triplets of the element of A in which at least 2 coordinates are equal. So required number of triplets is number of triplets without repetition minus number of triplets with repetition. So we have n cube minus n into n minus 1 into n minus 2. This is essentially nc. This is essentially n p3. Okay. So yeah, this is np3. So we have on solving this 3n square minus 2n. So with this, we come to the end of 38th set of problem on permutation and combination. Now to show my website, you come to ashtavakra.org. The second, third, and fourth books are of algebra, trigonometry, and coordinate geometry respectively. Notice the date. It is year first, followed by month, followed by day. So when you download, this date will not be there. So you need to add the date in your downloaded file, and around say after 15 days, you come and visit. If you see that date is changed, then you download again and update the date again. That's how you can maintain the updated version. For example, algebra book will receive update very soon, so this date will change. I cannot put this date in the file because if I do that, then I will have to update all the YouTube links, which is basically too hard for me. And trigonometry book is being worked on, and we will have conic sections completed very soon. Also, I'm starting a question answer website where you can register and ask questions over there. So we'll have that as well. So I hope that you're enjoying this playlist and finding them useful. So I wish you best luck in your studies, and I thank you for watching the video. We will meet again tomorrow with 10 more problems. So thanks a lot again for watching the video. I'll take my leave, and you should keep practicing and have a nice day.